This is problem number 8 from section 5.4. In this problem, they want you to find the linearization of f of x equals 5 minus the integral from 6 to x plus 1 of 20 over 4 plus t dt at x equals 5. So, to find a linearization, I have this formula here, which says, and if you watch the video on YouTube, they do a great job of explaining the formula. But they say the linearization equals f of a plus f prime of a, remember f prime of a is just the slope, times x minus a. This is actually, and they'll explain this in a YouTube video, this is actually just point slope form. Linearization means make this thing into a linear function. It's essentially like an estimation of the function at a specific point, and we're making that estimation into a linear line versus a curved line. And it's very specific to different points on the graph. So again, this is like point slope form. So if we want to use this though, essentially we need to go through and we need to evaluate the function at a, and we need to evaluate the derivative of the function at a. So we're going to end up using the fundamental theorem of calculus to figure this problem out. Let's first of all do f of a. So we know f of a is going to equal, well in our case a is 5. So we're going to evaluate f of a at 5. So if we do that, we would end up with, that's really just f of 5, which is equal to 5 minus the integral from 6 to 5 plus 1 of 20 over 4 plus 5. Well, 4 plus t. So essentially we're going to end up with 5 minus the integral from 6 to 6. Now you'll figure this out. I'm not sure if they've shown this before in the videos, but if you have an integral from 6 to the same number, that's just 0. So actually our answer, f of a, is really just going to be 5. So f of a is 5. We're going to write that here. F of a equals 5. And it should make sense why this would be 0. You're essentially going to, if you were to integrate this and then do, and then plug in 6 and then subtract out 6 plugged in, you end up with 0. So that's why the integral from 6 to 6 is 0, because you plug in the same thing and you subtract them, well that's going to be 0. So f of a is 5. So we know that this part of the linearization formula is 5. And we also know what a is. We know a is 5. So we need to go through and we need to then figure out what is f prime of a. So what are they really asking you? They're saying find the derivative of f of x. Well, f of x has an integral in it. So they're really asking you to find f prime of 5. We know to be the derivative with respect to x of 5 minus the derivative with respect to x of the integral 6 to x plus 1, 20 over 4 plus t dt. Now, we're going to use the fundamental theorem of calculus, and they show you a short version in the view and example, but I'm going to do the long version that we've been using. So let's go ahead and say that f of, we're going to call this, I'm going to call this g of x this time. So we're going to say g of x is going to equal 20 over 4 plus t. And then I want you to realize that when I refer to, because you're going to see me use this, capital G of x, that's going to be the integrated function. So let's go ahead and replace this. We can say that this equals, well the derivative of 5 is 0, so that's gone. So we end up with negative d over dx. of the integral 6 to x plus 1. And this time I'm going to replace this with g of x. G of x. Oh, and I should have said g of t, sorry. G of t, because we have the with respect to t. So g of t dt. My bad. That equals negative d over dx. If I do the derivative there, that would be capital G of t, and I'm going to evaluate that from 6 to x plus 1. Well, I know that to be equal to negative d over dx of g x plus 1 minus, well, when I plug in 6, I get g of 6. If I take the derivative then of g of this function g, I end up with just little g again, right? Because big G was my integrated version, so I go back to little g. So I've got negative, if I do the derivative of this, I get g of x plus 1, but I have to multiply it by because this is chain rule, I got to multiply it by the derivative of the inside. Well, the derivative of the inside is just 1, so I take it times 1. And then I do the derivative of g of 6. Well, this is just a constant, so that's going to be 0. So I can even say that that's just plus 0. So that gives me negative g of x plus 1, which now I can actually evaluate that negative g of x plus 1. Well, the g function is 20 over 4 plus t, so if I plug in x plus 1 into this, I end up with negative 20 over 4 plus, and I replace the t with the x plus 1, so x plus 1. So that really gives me negative 20 over 5 plus x. So now I can evaluate this. Remember at the very beginning we said f prime of 5. So our input, our x value should be 5. So I can plug 5 in now and I end up with negative 20 over 5 plus 5. So my slope for this function is negative 20 over 10, which is negative 2. So f prime of 5 was negative 2. And I used that, I found that out doing the fundamental theorem of calculus here. So now that I know the f prime of, well, in this case, our a is 5, right? So f prime of a we found to be 5. I know that this gives you negative 2, and I know that a is 5. So I can write this function out. So our linearization here is equal to, well, f of a, we know is 5, so 5. Well, in this case, I have f prime of a is negative 2, so 5 minus 2, and it's x minus 5. So I can then distribute, and I end up with 5 minus 2x plus 10. So I end up with negative 2x plus 15. And that's the linearization for this problem.